Okay, so let's go through this. First thing we need to figure out is this standard or metric?
That is standard.
How do we know it's standard? It's an inch caliper. How do we know that?
0.001.
It's 0.001. That's a start. Sometimes they'll even say inches in there. Also, a metric does not have dual labels here. This is 4, 1, 2, 3, 4, 5. Metric is not done that. Metric's just labeled 1, 2, 3, 4, 5. There is no numbers in between. So this is, how do we read this one? The 4, is that whole inches or tenths of an inch? It's whole inches. So it's 4 point, is this 9? How do we know it's not 9?
Because it's almost at the 0.
Not to the 0 yet. So it's 4.8. It has not made it to the 9 yet. And then this is 8.7. So this goes on the end of it. So 4.887. This one's a little bit different style. How would we read this one? Still 1 whole inches. Is it past the 6?
Yes.
Yes, it just passed 0. So it is past the 6. That says 9. So is it 1.69?
No, 1.609.
09. Very good. It has to have 2 digits off of the dial. So since it's just a 9, it's a 09. So 1.609 inches. Is it important that I say inches?
Yes.
Yes, it is. Very good. I'm not going to review the 16th or the 64th inch. How about this one? Well, first thing we notice is that it actually says millimeters there. But are these millimeters?
No.
No, those are centimeters. So this is actually not 4 centimeters or 40 millimeters. So now we read this at this edge. So this is 80, 85, 6. Is it past the 87? No, because it's not back to 0. So it is just 86.81 millimeters. This one? 22.37 millimeters.
On those kind of calipers, when they bevel the edge like at the bottom of the long forks there, is
Yep.
there any special reason? Or,
Like down here?
yeah.
That's just maybe so you can get into smaller places is all.
I mean, the inside there where,
Oh, this little notch out of here?
no, well, that too.
Or right here?
Yeah, you know, like on the, how it's doubled like that at the other end there.
Yep. They're made,
Yeah, like.
what they're made is so if you're on a concave surface, if you're on a curved surface, like let's say you're measuring a thickness here, they bevel them so you can get that sharp tip there and it can hit a point rather than having to be spread out. Because if that's because if you're hitting a point like that, you can hit it exact. But if it's a wider thing, if it hits like this, notice there's a little gap there. It doesn't quite get all the way down in. Yeah, it's actually more precise to measure with a needle point than it is with the head of a pencil. I'm gonna put that one away and pull up this one. So, first, metric or standard? This is standard. This is inches. So, does this 6 here mean inches or tenths? It is tenths. On a micrometer, it is tenths. Very good. So that's 0.6. Then what do we do with this part over here? Well, what else do we need to do? Are we all done? Are we ready to move over here? No. This is 0.6. That's not half. That's quarter in standard. So 0.625. And then this is on 1. So 0.001. So 0.626 inches. How do I read this one? This is metric. So this is 20 millimeters. This would be 21. Have we passed the 21 or are we just up to it? yeah, this is the 5, so it means we just passed 0. So we just passed 21. Is that 21.5? 0.5. This one, that one's a better one. There, this one's what I want to read. So, 15, 16, 17.5. Then what? Perfect. So plus the 35 here, so 17.85. What units? Millimeters.
I think we did the half.
Yep, on these we do the halves. Because this only goes from 0 to 50 on the dial, on the thimble. So on this one, inside, it's 3.5. There's the half-inch spacer here too. So we start out with 3.5. Then this is 0.125. We're past the quarter. And then this is 0.010. 3.635 inches. Look familiar? Those are tough, aren't they? Those suck a bit. How about this one? What's that? The inside ones? Yeah, possibly. How about this one? This is inches, yeah, because there's 4 marks in between numbered spots. 0.425. And then what? It's 9. So 0.434 inches. Yeah. How's about this one? 3.5. And then 0.325. And 0.012. 738, 3.837. Units? Inches. What if? What? What if I give you a quiz?
I'm not trying to push for it.
I don't know. It kind of sounds like you are. So if I were reading this just like it is, what would I read this as? Point, not 6 point, but 0.675. And then over here, it's between the 7 and the 8. Which one would I read it as? Closer to the 8. 0.683 inches. How does this change, though, if I add this? What did I just add?
6.
A vernier scale, right? So now if I read this down here, it is still 0.675, but it is not 0.008, it is 0.007. When we have a vernier scale up here, we always go down to the smallest one. If it's between, we go to the smaller one. Why? Because this number here is going to tell us how far we are past the smaller one. Yeah, we are closer to the 8, but we're not past the 8. Does that make sense?
Yeah.
So it is the 7. We add that on. And how far are we past the 0.682? We are the 6 that lines up. So it's really not 8, it's really 7.6 is where it's at, what that's telling us. What do you think of those? More fun than a barrel of monkeys? We're going to go ahead and start on our new material. We're going to talk a little bit about errors today. Not life errors, we're talking mathematical errors. So anyway, what we're looking at really is measurement errors. We talked about measuring devices and having built-in errors in the measuring device. Well, today we want to talk about errors beyond that, human error or operator error. Or it could actually be a part of that built-in error could be included in it as well, that error in our scale of the ruler. But anyway, what we're looking at, let's say we have an object that is actually 2 5/16 inches long. And we measure it, and because we have a measuring device that's only capable of going to the nearest eighth, let's say we measure it at 2 3/8 inches. We have an absolute error here. And the absolute error is just the difference between the actual and the measured. Now, it doesn't matter what order they are in. It's just the difference between them. So what we're going to do is we're going to put this little symbol around it. Those lines around it mean absolute value. So it's just how far apart they are. It doesn't matter which one's bigger. There is no positive or negative to this. There's just a difference. So in this case, since the measured value is actually bigger, we just do the 2 3/8 minus the 2 5/16. We get a 1/16 inch absolute error. Make sense? Well, then we have something called a relative error. Again, we're not talking about your family at all. Relative error is that absolute error over the actual value. So we have a 1/16 inch absolute error, and the actual value is 2 5/16. So that is what? I divide that out, I get 0.027. Now I could leave it like that as a relative error. Some books define a separate one called percent error. And some books claim that relative error and percent error are the same thing. Really, all you got to do to make it a percent error is move the decimal point 2 spots, makes it 2.7%. We went over percents before. So the percent error, this is the decimal form of the error, this is the percent form of the relative error. And I guess that's the way I usually define it, is this is the decimal form of relative error and this is the percent form. They are really the same thing. But if you hear if it asks for a percent error, you definitely want it this way. So you can see here a 1/16 inch absolute error is a 2.7% percent error, relative error. Now that's not that bad. The question becomes, how big does the absolute error have to be? Well, the percent error, the absolute error is generally more telling, because let's say that this is supposed to be, we measured it at 3/4 of an inch, and it actually was, I don't know, let's go 13/16. So now the measured is actually smaller than the actual, but still the absolute error is still just the difference. 13/16 minus 3/4. It's still a 1/16 inch absolute error. The difference is now, because the actual value is smaller, the relative error is 1/16 divided by 13/16. Give us 0.077, or 7.7%. In this case, that 1/16 inch is probably way too large. 7%, almost 8% error is definitely too big. Now up here, 2.7, almost 3% error, in many cases, that's too big. But if we had something that was, let's say it was 23 1/4 inches is the actual size. Well, now being off by a 1/16 inch wouldn't be that much. Does that make sense? So the bigger the measurement is, the smaller the relative error is likely to be just because of that comparison. Unless you really mess up the measurement. The next thing we want to talk about that kind of goes along with the errors is talk about percent error. That, the absolute error. If we given a percent error, let's say we have something that is measured at 18.5 inches, and we say that is within 2%, plus or minus 2%. So we got to figure out how much is that? Well, we're going to find 2%. 2 over 100 is how much out of 18.5? That's 0.37 inches. So this is 18.5 plus or minus 0.37 inches. Does that make sense? 37/100ths of an inch. I'll rewrite that so you can read it. Because 2% of 18.5 is 0.37. Now, where this comes into play more often is when we're dealing with tolerances. We might be given a part like this, and it might be labeled 1.200 inches plus or minus 0.005 inches. What does that mean? Well, it means we want that part to be 1.2, but yeah, it can be 5 thousandths smaller or 5 thousandths larger.
1.205 or 1.995.
Perfect. It can be anywhere from 1.195 inches to 1.205 inches. There's our range. How about this one? Same type of thing, though we got to figure out what that percent is first. So that's 0.4 out of 100. 0.4% is 0.4 out of 100. How much is that out of 1.5? Well, that is what? 0.006, is that correct? 0.4 times 1.5 divided by 100. So 0.4 times 1.5 divided by 100. 0.006, yeah. This is the 1.500 here times the 0.4. Cross multiply and divide, remember?
Yep.
So this is really, what that's really saying is 1.500 inches plus or minus 0.006 inches, giving us a range of 1.496 to 1.494, you're right, sorry. A minimum of 1.494 to a maximum of 1.506. And there are a lot of cases where they ask for the maximum first instead of the minimum, so you gotta be careful with that. This is a tolerance. This would be said to have a tolerance of 10 thousandths of an inch. Why is it said to have a tolerance of 10 thousandths of an inch? Well, because the difference between the minimum and the maximum and the minimum is 10 thousandths. So plus or minus 0.005, plus or minus 5 thousandths is really a 10 thousandths tolerance. This would be then a 12 thousandths of an inch tolerance. Does that make sense?
Well, and all you really have to do is take your plus or minus and
Yeah.
double it.
Yeah, pretty much. Unless,
Because you can have a min and a max. The up or down direction varying.
unless you have something like this.
And then you're talking 0.010.
Well, what is this saying?
You can't be plus, but you can be minus that number, 0.010.
Exactly. We cannot be larger, but we can be smaller by 10,000. This is giving us a range of 0.740 inches to 0.750 inches. Now, from the range, let's say I'm given the range and I want to go back to the tolerance. I could do that. Let's see up here, let's say I'm given, 1.438 inches to 1.462 inches. Can I find that desired value and then the allowance? Yeah, how would I find the desired value?
1462 minus 1.438 divided by 2.
Not minus, added together. You're going to average them together. It'll be 1.450. That's your desired value. Now to get the plus or minus, now you would subtract them. This is going to give you a plus or minus 0.012. So we can get that. So if we work this range backwards here, we add them together and divide by 2 would be 0.745 plus or minus 0.005. We subtract and divide by 2 is plus or minus 0.005. Why would we not write it like this instead of like this? Isn't this simpler? Well, yeah, it is, but it's about what we really want. We don't want this part to be 0.745. We really want it to be 0.750. Now, you guys are not machinists, but this kind of goes into the machining and fabricating side of it. What these numbers here, the plus or minuses, is telling the person who's building this part, okay, you know your machine. Let's say your machine is capable of going plus or minus 2 thousandths. That's fine. I'm going to shoot for 745, and most of those parts are going to go between 743 and 747, right? But if I see this and I know my machine is good to go within plus or minus 2 thousandths, I'm going to set my machine at 0.748 or 747 or something like that, so that most of my parts are between 746 and 750, because I want them to be as close to 750 as possible. Okay. So you don't always shoot for the center if you want it closer to one end or not. And the reason you know you can get closer to one end is you know the tolerance of the machine you're using to fabricate it.
Well, that would be actually below, because you have no upper tolerance.
Yeah. Yeah. But I mean, if you did it this way, if you listed it this way, it gives you the same range, but the machinist would be shooting for this. No matter what the plus or minus on his equipment is, he's going to shoot for the 0.745. But if his plus or minus on his equipment is less than the 5 thousandths, he could, using this one, he could shoot a little bit closer to the 750 instead of going 745. If it's a plus or minus 4 or 5 thousandths on the machine, if it's an older machine that's a little sloppier, he may still have to shoot for 745. But if he's got one that's a little bit better, they can get within 2 or maybe even 1 thousandth. He can shoot 748, 747, somewhere in there to get a little. And that's just it's telling the person who's creating the part what your intent really is. So let's take a look. Let's say our desired dimension, our allowance. Now the allowance is sometimes called a tolerance. Some books call this the allowance the tolerance. And then what do we call the tolerance? It sometimes calls it the tolerance range. Or tolerance interval. So let's say I give you a desired dimension of 2.150 inches. An allowance of plus or minus 0.010 inches. What is my upper limit going to be? 2.160. Upper means you're going to add this to it. Lower is then going to be 2.140 inches. And then the tolerance interval, is the difference between the upper and lower. Very good. Okay, well, in your textbooks, on page 198, it is exercise 4.7, 1 through 41, the odds. Again, take a look at the book, make sure that the vocabulary of the book, there's several different vocabulary words that go with this, and different books describe it differently. I'm describing the terms that I'm used to using, so you may have some different terms in the book.